4 days ago, this research paper just dropped. It introduces a new approach called DragGan, which allows us to manipulate images like never before. First, a quick overview of what GAN is. Generative Adversarial Networks, GANs. It's a type of machine learning model that can generate new data that is similar to a given dataset that we want. GANs have two parts, a generator and a discriminator. So let's say I want to create or generate a picture of a golden retriever. The generator will try to generate a picture that is similar to the real picture we want. The discriminator takes in both the real picture of the golden retriever and the generated picture and tries to tell the difference between the two. The generator and discriminator are trained together. It's like a game where the generator tries to fool the discriminator into thinking that the generated data is real, while the discriminator tries to correctly identify which data is real and which is generated. Over time, the generator gets better at generating realistic data, and the discriminator gets better at telling the difference between real and generated data. This process continues until the generator is able to generate data that is very similar, making it difficult for the discriminator to tell the difference. So basically, for each iteration, the picture of the golden retriever will get more realistic. So now for DragGan. DragGan have two key components that work together to achieve this image manipulation. The first component is a feature-based motion supervision technique that allows us to drag specific points of the image toward desired target positions. That's the ability to move any point on any image and watch it smoothly glide exactly where we want it. This is done through a clever loss function that guides a small patch around the handle points, that's what we want to move, to gradually move to the target point where we want to move it. By optimizing the latent code through multiple iterations, the handle points progressively approach their targets. This is done by comparing the features of a small patch around the target point. The loss function encourages these two patches to have similar features, which in turn encourages the handle point to move closer to the target point. And this gives us precise control over the shape, expression, and layout of any object, including animals, cars, humans, landscapes, facial expressions. The possibilities here are really endless. And the second component of DragGan is a new point tracking approach that uses the discriminative feature of the generator. It keeps track of the positions of our handle point across multiple optimization steps. The algorithm finds the best match for each handle point in the next optimization step, even when the point undergoes significant deformation or changes in appearance. That's how we can manipulate the images instantly while maintaining accuracy and stability. One of the most impressive aspects of DragGan is its ability to produce realistic outputs, even in challenging scenarios. It is actually able to hallucinate occluded content or deform shapes. For instance, DragGan can realistically create the appearance of teeth inside of a lion's mouth when it's opened, or bend a horse's leg while preserving its natural rigidity. Because DragGan doesn't just use the image, but taps into the learned generative image manifold of a GAN, which captures the underlying structure and appearance of the object. And this sets DragGan apart from traditional shape deforming techniques that often rely on simple warping approaches like Photoshop. And one more thing the paper throws at us: they showcased how DragGan can be used to manipulate real images through a process called GAN inversion. This means DragGan is not limited to synthetic images, but can also be applied to real-world photographs, opening up a whole new realm of creative possibilities. We are going to be able to transform images like never before. But we can never trust a smile or an emotion in social media ever again. Thank you for watching, and I will see you in the next one.